my project was interdisciplinary, and so from the psychology, we were interested in looking at the evolution of general intelligence. Now, there are two interesting research concepts or findings in psychology. First is called the generalist genes hypothesis, which says that the genes associated with certain learning ability or disability are the same genes that are associated with some other learning or cognitive ability and disability. For instance, genes that help us learn mathematics are the same genes that help us learn how to read, or in memory, or like visual processing or spatial processing. So that was one thing. And another interesting research concept in psychology is called the notion of transfer, which says that we have the ability to intelligently apply knowledge which we acquired whilst learning one thing to solve new problems faster and with better solutions. So for example, the abilities that we acquire whilst learning to walk help you in learning to run, or like learning maths helps later on in learning physics. So these were the two interesting research findings from psychology that I took as the core. So drawing inspiration from these two psychological research findings, I developed a computational framework which enables a population of artificial neural networks to evolve their general ability to learn or the learning predisposition by encoding their intrinsic properties in an artificial genome. And then we worked on transferring this general ability to learn across different problem domains. For example, language acquisition, cognitive imitation, or random mappings, etc. And the biggest advantage is that having this method, it prevents the need for reinventing the wheel every time the population of neural networks comes across a different task or unrelated task, or every time the environment within which those learning systems are placed, it changes. So you don't have to like do it over and over again. And therefore, I would say my research is a small step towards designing systems for artificial general intelligence. So that means you're coming up with approaches that help them learn not just one skill, but also various other skills without affecting their performance on the previously held knowledge. So for example, in my case, the first task the population of neural networks had to learn was the acquisition of English past tense. And then you can do it like sequentially, parallelly, doesn't matter. They also learn cognitive imitation, random mappings, categorization, and categorization with exceptions. So there were like 5 tasks that I trained them on. And by having this method based on evolving the general ability to learn and the effect of selection and sexual reproduction, etc. Yes, the population of neural networks, and I trained over 200,000 neural networks, they were successfully able to learn all 5 tasks and perform good, like have good performance. So yeah.